time to debuggers, guys. Debuggers, again, is something that you must do to understand what the malware is doing, but you need to do it wisely because you don't want to spend too much time on it. And that's why we talk about the Carnita methodology. You will see how we tackle these problems so that we can be efficient while analyzing malware. So again, one of our old school tools, Immunity Debugger. This tool used to belong to Immunity Inc., which was a company from famous hacker Dave Attell. Is no longer, actually Immunity is no longer a company, it was acquired, but the website is still up and running. You can still go and download this tool. It is for 32 bits binaries. It is actually based on the very famous WinDbg. But what they do is that they portrait it in order to have a Python-based control of that tool, which allows them to write multiple plugins in Python for the debugger. It's 32 bits only. They never added 64-bit version. It was always expected back in the day, but again, it's pretty cool. If you have a 32-bit binary you want to analyze, it's always good to go with Immunity Debugger. It's in our environment. It runs on Python 2.7. Again, it's old, but it's one of those tools that you have in the lab, old school tools that we don't want to get rid of. Okay. Again, as a debugger, it executes step by step. It supports Python version 2.7, so that it adds a lot of plugins, and you can also add new plugins to the debugger. Not something that we're gonna do, not something that we're gonna be doing, because it's not something useful for us. Okay. Nice syntax color. Used to be supported by Immunity, as I said, and it's free. You know, it's one of those old tools we're gonna keep in our lab. WinDbg. WinDbg is another debugger from Windows. This is natively supported by Windows. It's free. The good news about this tool is that it supports 32-bit and 64 bits, and is not that friendly, as you can see. It has its challenges. Sometimes people don't use it because of that, but it's actually pretty powerful. It's the most powerful tool because it talks directly to the native operating system. It gives you a lot of context, even though it's not that friendly. There is a latest version that is more friendly in the UI, user interface, so you will check in the labs. And basically what we use in this tool is the sauce plugin, and I'm gonna tell you why in a second. Okay, so it is pretty useful also for kernel analysis. You know, if you have a rootkit in the system, we might add some labs for that. Rootkits are not that common lately, but we might add some rootkits if we see a new wave of malware coming in. But definitely is the way to go for kernel debugging. Again, it executes malware step by step. It supports Python also, you know, to automate stuff. Again, it knows all the Windows internal structures, so that's something that no one else is gonna give you. Okay, or not, at least not in the way WinDbg does. As I said, very useful for analyze Windows drivers or rootkits. Fully supported by Microsoft, works on 32 and 64-bit binaries, and for us, we have very cool labs where we're gonna be using it with the sauce plugin. The sauce plugin allows us to analyze .NET managed code, and we have pretty cool labs where we're gonna be switching between DN Spy, which is a tool that you are gonna also see in the labs, with WinDbg, and combining those tools, we're gonna be able to analyze .NET pretty quick and pretty nice. Disassembler. There are many disassemblers in the market nowadays. There is one from NSA released called Jidra or Jydra, very common one. But guys, you can always learn anything you want. I just wanna teach you IDA. IDA is the best tool it has been for disassembling, and the pretty cool news is that now IDA free, the free version, comes with the debugger and comes with the disassembler, which can give us debugger, disassembler, and with the with a plugin that can provide us with the pseudocode, okay, which means we can also see the C or C++ version of the assembly, which is pretty cool. That was not available back in the day, and that's available for 32 and 64 bits binaries on Windows, which is exactly what we need. And it's pretty cool because it has multiple views. You will see it in the lab, and it is, to me, the best tool for a reverser. Even though Jidra is there and many other tools are there, like Binary Ninja. Again, it's up to you guys to use other tools always, but to me, IDA Pro is what you're gonna be learning here, and is actually the best in my opinion. Okay, to me, it's the best disassembler. It has a free and commercial version. Actually, the commercial version is very expensive, but normally it is being sponsored by the companies. If you work for a company that do malware analysis, you will have this license acquired. It is around, I would say, $1,500, the basic, all up to even $4,000 to $5,000, guys. So it's crazy because they charge for also every single plugin to do the pseudocode of multiple architectures. Okay. As I said, the decompiler comes with the free version of 64-bit, so that's great for us for our analysis. So we're gonna be using it, and the commercial version supports other architectures like Intel, obviously, 32, 64, 80, 86, which is very old version, ARM, PPC, MIPS, which are other architectures which are out of the scope of our. Last but not least, guys, let's talk about binary emulation, okay? And as I promised, once you understand how to analyze a malware, now that you understood the function that decrypts the strings, or the function that decode the malware in memory, or the address where the malware starts jumping into another process, then you can start automating this so that you can dump it from memory, and then you don't wanna tackle one malware at a time, because that way we're gonna be losing the battle against the attackers, right? We really wanna be able to understand once and then get 100s, 200s, 2000s of samples, similar samples, and then just automate the process to do, again, whatever you want. Extract IOCs, dump strings from memory, decrypt strings from a specific function, get a second stage binary downloaded. Whatever you need can be automated, as long as you understand how the malware works. Okay, so we're gonna be using Qilinq from our Chinese guys. Pretty cool, amazing. Kudos for those guys. It's emulate multiple platforms. In other words, that means that it can generate code in Windows, Mac, Linux, Android, anything you need. For us, it's gonna be Windows in this time, but with the same API, the same framework, you can do it in other platforms. It can also emulate multiple architectures, like x86, which is 32 bits on Intel, x86-64, which is 64-bit version of Intel or AMD, ARM64, MISP, RISC-V, PowerPC. Those other architectures, again, are not in our scope, but you have the same framework to do that magic. Okay, it's pretty cool. In instrumentation, means that you control the execution of a file, of a program at runtime. You can tell them what to execute, what not, and actually you can update the registers and you can fully control what the binary is doing. So when we can hook, if you remember, guys, is a way for you to intercept specific instructions. So you can get, when an instruction is being called, you can intercept it. When a memory access is done for a specific region, you can intercept it. When there is an exception, when there is a syscall, syscall is a specific function being called by the operating system, you can intercept it. Even IOs, which is more into kernel mode. So it's pretty amazing, and you can basically watch and intercept whatever the binary is doing. Okay, this is pretty cool also. It acts as a virtual machine, so you can even save and restore the stage of the binary. So you can run the binary. You can run the binary to an stage that, let's suppose that the malware is about to dump something from memory, and you can store that state at that moment, and then later reopen the binary and resume execution. That beauty can be done through a Python script because it supports Python, and actually it runs with Python. Okay, it has a built-in debugger also that you can use. You can hot patch the binary in memory, so you can go and say, hey, when you reach this instruction, change the register in the CPU, or change a specific offset in the binary. So it's actually pretty amazing, and as I said, it runs with Python, so it's all on your hands. Here's a quick example, guys, and we're gonna be doing this a lot in our labs. Okay, so for example, in this case, let's suppose that we have a DLL. As you remember, a DLL is a dynamic loaded library, which basically means that it's a file that needs to be loaded by another program, an executable. So we can use that DLL because Qilinq has loaders. Qilinq has a Windows loader that's gonna run and unload the DLL for us in memory, and you can tell them where it's gonna be loaded the DLL in memory, all the different parameters that the DLL needs to run, and then, for example, in this case, you can say, hey, you know what? Let's hook every single function that is being called. We're gonna know, and we're gonna print out every time it's being called. What you do is you create a function, in this case hook get proc address. Get proc address, guys, is a function used by Windows to get the address of the function about to be called. Okay, so if you're gonna be calling the load library function, it's gonna call get proc address to know where is load library located in memory, get the address, and execute it. So in this example, we can tell Qilinq, hey Qilinq, every time you see get proc address being called, print out the LP proc name, which what that means is the name of the module that is about to be loaded. Okay, so the next line, as you can see here, is the hook QL, which is the framework, set API, the name of the API, get proc address, pass it the name of the function that we created, the custom one, and the final command for Qilinq to exit properly. That's it. That's pretty much it, guys. You run this, it's gonna run the DLL, and every time the DLL start calling all those different functions in Windows, it's gonna intercept them, and as you can see in the right side, it's gonna start executing what's the name of the module about to be loaded. So that's pretty amazing, guys. And this is just obviously 101. So we're gonna be using Qilinq to automate a lot of stuff of the malware that we're learning, and you will learn it also. You will have a chance to play with this, which is pretty amazing, guys. So this is all for theory, and we'll see the next modules, and look forward for the labs, guys, for you to practice. And as a summary, we talk about PE editors, Lord PE, CFF Explorer, Hue, which are normal editors for you to see the format, to change the properties if you want, runtime monitoring for you to see how the malware is doing at runtime. We use on network traffic, how to capture the traffic either locally or in live mode without the malware even notice it. We talk about debuggers and disassemblers so that we can run malware and analyze it statically with Immunity Debugger, which is discontinued WinDbg and our greatest IDA Pro. And we talk about binary emulation so that we can automate the whole process, so that we can tackle and scale the speed of the way malware authors move. Thank you so much.